One cheap machine turns a $1 blank into a $30 finished product. Another makes unique souvenirs people pay $120 for. And 28 more machines, so you can start your own small business in your garage or even at home. We'll show you the best ones for different budgets and sizes, explain what they produce, how much they cost, and calculate the economics and feasibility behind each one. Pick up almost any promotional pin or plastic keychain and look at the logo. It's usually printed perfectly, even if the surface is curved or uneven. In most cases, this is done using pad printing, a process designed specifically for awkward shapes. The equipment itself is fairly straightforward, and once set up, the machine basically runs itself. A desktop pad printing machine suitable for small workshops typically costs around $2,000, which is enough for printing 1 or 2 color logos. More advanced machines with automatic feeding and larger work areas move closer to $4,000, but for garage-scale businesses, they rarely pay off faster. In real-world use, pad printing is common for markings on electronics, housings, and souvenir items like keychains, mugs, and of course, plates. Printing costs usually fall in the $1 to $4 range per item, while finished products sell for $6 to $18 each. This is a highly specialized laser built to perform one specific task, creating a three-dimensional image inside a solid glass blank. A focused laser works inside the glass, creating thousands of microscopic points at different depths. Individually, they're almost invisible, but together they form a floating image inside the crystal, while the surface remains perfectly smooth. Entry costs for this type of business aren't low. Practical machines start at around $6,000, but ongoing expenses are minimal, limited mostly to electricity and glass blanks. In practice, these crystals are ordered with 3D portraits of people or pets and sell for $40, $80, or with engraved ultrasound images, where materials and labor cost $6 to $10, and the final price for the customer often reaches $70 or more. Would you personally pay $120 for a glass crystal, or only if it's extremely personal? A plate embossing machine doesn't create a product from scratch. It changes the status of the material. A plain metal sheet is raw material. Once a textured pattern is embossed into it, it becomes a finished product with function and value. Texture adds two things at once: utility and appearance. That's where margin comes from. The base sheet is priced as a sheet. After embossing, it's sold as a specialized material, anti-slip flooring, wall panels, or industrial surfaces. Price per square foot can increase several times over, while the processing cost remains minimal. It's one of the most direct ways to turn cheap raw material into a higher value product. Base metal sheets might cost only a few dollars per square foot, while embossed material often sells 2 to 4 times higher, with processing usually adding only a few cents per square foot. Rust and old paint are routine problems for auto shops, industrial sites, and private properties. A fiber laser cleaning machine is one of the tools used when metal needs to be cleaned precisely and without additional surface treatment. Basic mobile units start at around $7,000, while more powerful and faster versions range from $12,000 to $15,000. The business model here is service-based. You arrive on site, set up the equipment, and remove rust without dirt, sand, or chemicals. The process is completely safe and can be handled by virtually anyone, even without prior experience. Cleaning automotive parts typically costs $40 to $60 per component. Larger jobs are usually billed by time, with hourly rates commonly ranging from $70 to $100. There are no consumables beyond electricity, and the laser source itself is rated for thousands of operating hours. You may have seen concepts where people intentionally break a mirror and then assemble the fragments into a composition. This follows a similar idea, but in a controlled and deliberate way. Instead of chaos, there's precision cutting. Instead of random shards, there's intentional design that looks like art, not an accident. The raw material remains ordinary mirror glass, but once it's cut and assembled, the result is sold as decor. Small compositions commonly sell for $50 to $150, while larger panels or custom installations for specific spaces go much higher. The price isn't driven by technical complexity, but by how the piece works in an interior. At the core is a compact mirror-cutting machine that produces elements of predefined shapes. From there, the value is created by composition, spacing, layout, lighting, and background. With this machine, you can immediately see what you're producing. Threads feed into a cylinder, needles follow a program pattern, and within minutes, a finished sock comes out. The money isn't in basic socks. Plain designs compete directly with factories and leave little margin. The real value of this type of machine is customization. Multiple colors in one pair, different sock lengths, densities, heel zones, and full visibility of the knitting process in real time. This opens the door to themed designs and custom orders that comfortably sell for $8 to $15 per pair, and more when sold in sets. With production costs of just a few dollars per pair, even small volumes can generate noticeable profit. Entry-level machines usually cost around $3,000, while faster and more stable models range from $8,000 to $10,000. This is a straightforward product business with a clear, linear workflow. You purchase blank phone cases for popular models, prepare or upload a design, and place each case on the table of a UV printer, which prints the image directly onto the surface. Desktop UV printers made specifically for phone cases typically start at around $3,000. Blank cases usually cost about $2 each, and ink consumption is low, adding roughly $1 per unit, which brings the total production cost to approximately $2 to $5 per finished case. The process is relatively quiet and produces little odor, making it suitable for a home setup. Finished designer cases commonly sell for $20, while personalized options with photos, names, or custom artwork often command $30 or more. Or do you think the market is already oversaturated? This is one of those machines where the entry cost is low and the range of applications is limited mostly by imagination. A desktop vacuum former starting at around $500 doesn't produce finished products by itself. It shapes plastic over custom molds, which allows it to cover dozens of small but profitable tasks. Some clients need packaging, others need protective covers, temporary housings, or molds for casting. Instead of ordering expensive injection molds that cost thousands of dollars, you make the form yourself and produce plastic parts within minutes. What isn't viable for factories, batches of 20-50 pieces, is exactly the sweet spot for vacuum forming. Clients pay for speed and flexibility without waiting weeks or dealing with large contractors. Xtool P3 received a CES Innovation Awards Honoree Award at Consumer Electronics Show, one of the world's largest technology exhibitions, underscoring its professional positioning despite the desktop format. Designed for indoor use, it features an enclosed frame, a built-in camera, and mature software that require no modifications for home or studio operation. The machine is capable of both cutting and engraving and works with wood, plywood, leather, acrylic, cardboard, rubber, and fabrics. In practice, it's commonly used for personalized products, small batches of decorative items, leather goods, signs, organizers, and acrylic parts, where items with production costs of $1 to $3 often sell for $15 to $40. Traditional hot stamping always relies on physical dies, metal plates that take time to produce and limit flexibility. In newer automated machines, the logic is different. The system connects directly to a laptop and works from a digital file, without interchangeable dies or mechanical molds. In essence, it's digital hot stamping. You upload a design, select the stamping area, material, and foil type, and the machine forms the image using precise heat and pressure. This allows designs to be changed between products without downtime and makes short runs or even single pieces economically viable. These machines usually cost more than basic presses but still remain within a reasonable range for small workshops, typically around $4,000 to $8,000. If you look at new clothing brands, most follow the same path by relying on printed graphics, while embroidery stands out as a more durable and premium-looking alternative that customers are willing to pay extra for. An embroidered logo can add $10 to $30 to the price of a hoodie, cap, or bag, which is why many brands choose this approach early on. A sewing and embroidery machine combines two functions in one setup. It works as a standard sewing machine for hemming, assembling, and modifying garments, and at the same time serves as a full computer-controlled embroidery system. You load a design file, choose the size and placement, secure the item, and the machine stitches the pattern layer by layer, producing a consistent, professional result. This machine doesn't work with a specific product, it works with shape. If an item can be fixed in place and rotated along its axis, it can be printed on. The object spins in sync with the movement of the print head, allowing the image to wrap evenly around the entire circumference. That's why the same setup works for bottles, mugs, glasses, candles and glass, and other cylindrical items. This versatility is exactly where the money comes from. A UV printer with a rotary axis typically costs between $5,000 and $10,000, while the printing cost per unit stays around $2. Mugs and glasses commonly sell for $15, bottles and insulated tumblers for $50, and corporate or gift orders often reach $70 to $120 per item. Multiply that amount by 30 employees in a company, and you're looking at a single order worth $2,100 to $3,600. You can make money machining metal without a full workshop, staff, or major capital investment. A compact desktop CNC mill designed for small parts is enough, with entry-level machines starting at around $2,500. These machines work not only with metal, but also with wood, plastics, and composites, allowing real products to be made in a home workshop. Despite their size, they're not toys. They're used to produce small mechanical components, housings, brackets, and custom parts. Exactly the kind of work that large factories don't want, but customers are willing to pay for. Clients are usually found on platforms like Upwork and Etsy, or directly through engineering, maker, and hobbyist communities where one-off and custom results are always in demand. Home coffee roasting in small batches means buying green coffee beans, choosing your own roast profile, and selling the finished product yourself. The math here is very transparent. Quality green coffee in the US usually costs around $5 to $8 per pound. After roasting, the weight drops, but even accounting for losses, production costs rarely exceed $7 to $10 per pound. That same coffee, once roasted, labeled with origin, roast profile, and roast date, comfortably sells for $18 to $30 per pound, and sometimes more for rare origins or microlots. The difference isn't in the technology, but in added value. From there, variation kicks in. The same bean can be roasted multiple ways, instantly turning one product into several. Would you buy coffee from a local micro roaster if it costs double supermarket coffee? Standard printing on fabric or leather always stays on the surface. Over time, it wears off, cracks, or simply looks cheap. Instead, a fabric or leather blank is placed between molds. Settings are selected, and the machine presses the design into the surface. The result is a textured pattern that doesn't fade or peel because it becomes part of the material itself. In practice, this method is used for belts, wallets, cases, logos, and decorative patterns on bags and backpacks, where finished products sell in the $50 to $120 range. There are limitations. It's not suitable for very thin or loose fabrics, and designs can't be changed instantly without preparation. When most people think about custom rings, they imagine the same process. A finished ring blank is placed under a laser, and a dark engraving is burned onto the surface. That's the most common method, fast, but essentially just a surface mark. There is, however, equipment that works very differently. It doesn't burn the metal, it physically cuts letters and symbols into it. This isn't engraving, it's carving. The difference is obvious even on marketplaces like Etsy. Laser engraved rings sell for around $20 to $30, while carved rings sit in a completely different segment at $100, $150, sometimes even $200 per piece. The key advantage is automation. The ring is fixed perfectly on axis, and the cutting path follows the design defined in the software. In China, jade is considered a stone of luck, but the real luck is that it sells well, especially when turned into well-designed products. A jade cutting machine allows you to produce jewelry, pendants, and keychains. It cuts digitally based on predefined designs or custom templates, which means you can produce repeatable items or fully custom pieces. The machine itself costs around $3,000. A single carved jade pendant with a personalized pattern can sell for $25 to $40, particularly on platforms like Etsy, where buyers actively look for symbolic or customized gifts. After socks, the logical next step is to move further along the same chain, not by increasing volume, but by increasing the value of a single item. That step is sweaters. It's still knitting and yarn, but the product changes from an accessory to a full garment people are willing to pay more for. Yarn remains the main cost, and the production cost of one sweater is typically $8 to $15. The finished product sells as a complete clothing item for $40 to $80. At this point, small batches can already be profitable without relying on scale. A sweater knitting machine usually costs between $6,000 and $15,000. This is an automatic cookie forming machine, but not in the home kitchen sense. It can simply deposit dough, form different patterns, or operate in wire cut mode, where dough is extruded as a strip and automatically cut by a blade. Because of this, the same machine can produce multiple types of cookies instead of one signature shape. The entry cost isn't domestic, but it's not industrial either. Desktop depositors typically cost around $6,000. From there, the math of food products is straightforward. Ingredients are cheap, and added value comes from shape, consistency, and packaging. Paper plates appear wherever two things intersect. Food needs to be served quickly, and plastic disposal becomes less acceptable. This isn't an eco-trend, it's the result of regulations, events, catering, and street food, where disposable tableware isn't optional. The forming press sits in the middle of this chain. On the input side, there's cheap fiber, recycled paper, pulp, sometimes bamboo or sugarcane bagasse. On the output side, there's a rigid plate with a fixed shape that can handle hot food. What matters is that sustainability isn't the main selling point. For customers, it's simply an added bonus on top of a practical product. Raw material usually costs just a few cents per plate. Bulk prices average 8 to 20 cents, and small presses typically cost $3,000 to $6,000, with electricity as the main ongoing expense. Wooden tool handles, coffee tampers, and even designer candle holders can all be made on a single CNC wood lathe. Instead of doing everything by hand, you clamp a wooden blank into the spindle. The cutting tool follows the program path and literally shaves the wood layer by layer, forming the exact shape you need. In a couple of minutes, you're holding a finished part with consistent geometry from piece to piece. Wood and electricity usually cost well under $1 per item, while finished parts sell for $2 to $5 for basic products and significantly more for designer or specialized items. Pricing increases easily by switching to premium hardwoods or adding engraving during finishing. You've probably seen elastic hair ties used every day. They're produced on compact circular knitting machines designed specifically for small elastic accessories. Yarn feeds into the cylinder, needles knit a continuous elastic structure, and the output is a finished hair tie with consistent stretch and shape. The machines themselves typically cost around $3,000 to $5,000. The key advantage is efficiency. Large factories focus on massive volumes, while here you can produce smaller batches, experiment with colors, textures, and materials. Printing pages is easy, but real value appears at the moment a stack of paper turns into something you want to hold in your hands. That's where the combination of a printer and a notebook binding machine comes in. The pages are clamped together, glue is worked into the spine, the cover is pulled tight around the block, and in a few seconds the loose stack turns into a solid notebook. This is adhesive binding, the same principle used in large publishing. There's no need to order thousands of copies or wait for a print run. You can produce 10, 50, or 100 units, each with a different design, logo, or content. Production cost per notebook is usually $2 to $3, while retail prices start around $15. Heavier paper, custom covers, or clean design easily push pricing to $30 and beyond. In B2B, the same issue comes up again and again. A simple component is needed, but not in factory-scale quantities. Webbing straps fall squarely into this category. Backpack straps, cargo tie-downs, and bag handles are basic items, but as soon as a non-standard width, color, or density is required, large manufacturers lose interest. That's exactly where a strap weaving machine fits. It doesn't make a product, it solves a specific business need by quickly delivering the exact webbing required for an order. Threads are pulled through the guides, the machine interlaces them under tension, and a finished strip of webbing steadily feeds out the other side. The edges are sealed with a hot cutter so the material doesn't fray. The machine itself typically costs around $4,000, plus about $200 for the cutter. In construction, there's a type of fastener without which you can't secure wiring along a beam or stretch upholstery onto a base. These are construction staples, an invisible but constantly used consumable in installation and finishing work. They're usually bought in bulk, treated as expendable hardware, but they can also be produced locally. The raw material is standard metal wire, which is formed into staples sized precisely for specific types of construction staplers. Shape, thickness, and angle are standardized because compatibility matters more than variation. Profit here comes from volume. The main customers are contractors and job sites, where price, availability, and quantity matter more than branding. Additional sales come from direct-to-marketplace listings, packs of 1,000–2,000 units, especially in non-standard sizes. Many people think cotton pads are the simplest product imaginable, as if they're just punched out of loose cotton. In reality, the process is far more precise. The base material isn't fluffy cotton, but a specialized cotton fabric. Several layers are bonded together using ultrasound without glue or chemicals. The machine literally fuses the fibers, creating a strong edge that doesn't separate during use. Only after that does the blank move to cutting, where a precision blade forms perfectly uniform pads. The most challenging part is tuning the parameters. Pressure, ultrasonic frequency, and layer thickness all have to align. A slight mismatch, and the pad either falls apart or becomes too stiff and uncomfortable. That's why high-quality cotton pads aren't cheap throwaways. They're the result of a tightly controlled manufacturing process. Paper food trays are a direct extension of the same logic as paper plates. Once food stops being eaten at a table and starts being taken to go, a flat plate isn't always convenient. You need a format that can be held in one hand without spilling or burning yourself. Technologically, there's nothing radically new here. The difference is geometry. The shape is deeper, the sides are higher, and the structure is designed for different types of food. That change significantly expands how and where the product can be used. Barbed wire is one of the most basic products in agriculture and infrastructure. Because of that simplicity, the market relied on imports for a long time. But once logistics, tariffs, and regulations made shipping slower and more expensive, the reality became obvious. This product is better produced locally. Not because it's complex, but because it's heavy, bulky, and sold in thousands of feet. A barbed wire machine does exactly what it needs to. Two steel wires are fed in and twisted together, and at regular intervals, typically every 4–6 inches, sharp barbs are wrapped around them. The output is a standard coil containing 3 to 600 feet of finished wire, which sells for roughly 8 to 15 cents per foot. Tortillas are one of the few products where the core technology hasn't changed much in decades, yet demand has only grown. A tortilla machine didn't appear as an experiment, but as a natural step once production outgrows a kitchen setup. With it, the process becomes predictable. Dough is fed in, pressed, evenly heated, and comes out consistent from batch to batch. This directly affects both appearance and performance in finished dishes. The cost of a single tortilla is just a few cents. When sold at around 60 cents each, profit doesn't come from markup, but from volume and regular demand. This isn't a one-off or seasonal product. Tortillas are bought constantly. Most of the cost of a wooden pallet isn't in the boards themselves, but in everything around them: cutting, nails, and assembly. Press pallets remove that entire chain, leaving only shape and pressure. Sawdust and wood chips are mixed with a binder, fed into a mold, and compressed under high temperature. The result is a pallet with fixed geometry that doesn't loosen and resists moisture. The raw material is waste that furniture and woodworking shops often give away for free. The main costs are binder and energy. As a result, production cost per pallet usually falls in the $4 to $6 range, while selling prices reach $12 to $20 per unit. An additional advantage is logistics. Press pallets are about 25–30% lighter, stack better, and take up less space during transport. But if they are better, why haven't they completely replaced the standard ones?